Yeah, hello viewers at home. Thank you for watching our channel at King of Mathematics. Today, the video is going to be taking a new dimension in the sense that I'll be taking a topic in further mathematics, which is calculus. This topic is very important for secondary school students that are probably writing WAEC for further maths or mathematics. And it's also going to be helpful to the part 1 students that are offering mathematics. Alright, students of Obafemi Awolowo University were given a quiz on this particular calculus, and while I met with them I was able to solve, and some of them even said that if I could be solving some of their questions for them on my channel, that they too will love that part so that they can always watch my channel and tell their friend. So today I will be solving their quiz question. But before I start solving, I want to take us quickly on some topics on calculus before solving their quiz. So the first one is what I call quotient truth. That's when you have your y to be in the form u over v. And what we say is that the y dx will be equals to v du dx minus u dv dx all over v squared. Let's say example. Example is y is equal to 2x plus 1 all over 3x squared minus 2. So we say let u be equals to, let me have this, let u be equals to 2x plus 1 and v be equals to 3x squared minus 2. So on that note, when you find your du, because you are differentiating u in respect to x, you have du dx to be equals to, when you are doing that, that means you find the power of x here is 1. 1 times the coefficient of x, which is what? 2. So 1 times 2, that will give us 2. Then we subtract. We have, the formula is anytime you have y equals to a x raised power n, your dy dx is always equals to a n x raised power n minus 1. So that's what I'm using here. The power here is 1, which is our n. You use your n to multiply a, the coefficient, which is 2. Then n minus 1, that's what? 0. So that's why I'm having 1 minus, the power here is 1 minus 1, that's 0. X raised to power 0, that's 2x raised to power 1 minus 1. Then the differentiation of any constant is always equals to what? 0. So we forget about that one. So this one will give me 2 times x raised to power 0, which is equal to 2. Because anything raised to power 0 is 1 under indices. Then we go to the second one, dv dx, which will give us 2 times 3, that's what? 6x. 2 minus 1 is 1, that's 6x. Then differentiation of this constant will give us 0. So we go back to our dy dx, that dy dx will be equals to u, that's 2x plus 1, dv dx, we are sorry, not u, v, that's 3x squared minus 2. Then du dx is 2, that's times 2, minus v, that's minus u rather, that's 2x plus 1. Then we have dv dx is 6x. So all over v squared, which is 3x squared minus 2, all squared. So you can decide to open up the bracket 2 times, that will give us 6x squared minus 4, then minus 6x times this, that will give you 12. So let me put that minus in bracket, that's minus 12x squared, then plus 6x, everything over 3x squared minus 2, all squared. So once you've done this, then we can collect like terms, which will give me 6x squared minus 4 minus 12x squared minus 6x everything all over 3x squared minus 2 all squared. So this will be my dy dx. But let me now put it in the final form. 6 minus 12, that's minus 6. And that will give me minus 6x squared minus 6x minus 4 all over 3x squared minus 2 all squared, which is my dy dx. That's how to solve a question like this. I could see someone is asking a question that, can we leave our answer like this? Yes, you can leave your answer like that. It doesn't make you wrong. Then the second one I would like to point our mind to is what I call implicit function. Implicit function. So if y, for instance, let's say we have x squared y plus x equals to 2. This is an implicit function because it's having both x and y, and we want to get our dy dx. So the law for implicit function is that you must always differentiate. When you are differentiating in respect to y, you put your dy dx. If you are differentiating in respect to x, you not put anything. Let's see this. In this case, you can see if I divide this, here I'm having x squared and I'm having y. So if I want to differentiate in respect to x, I will see it like I'm not looking at my y. So here, let's we differentiate this one twice because we have x, y. But here, we differentiate it just one. There's no y. So if you differentiate this one, it will give you 2x. You know I'm differentiating in respect to x. That will give me 2x. Then I will add my y. 2xy. It will not have the y dx. Then I will do the second one. I will now say plus. Still this same one. So I'm now looking at and differentiating in respect to y. So when you differentiate y, you are going to have 1. So 1 times x squared, that's 1 times x squared. Then I'm going to now add my dy dx. What am I saying? Like now, you cover this the x squared. Before you differentiate this one, that's 1. Then you add the x squared, that's the x squared. You add dy dx because it's in respect to y. But here, we differentiated in respect to x. We forget about this, that will give you 2x. Then you add your y, that's why you have 2xy. So I'm done with this one now because it's adding x and y. Then I'll go to the last one, plus differentiation of, I'm differentiating in respect to x here. So differentiation of will give you ordinary 1. So equals to, differentiation of the constant is 0. Then we'll make the y dx the subject of formula. That will give me 2xy plus x squared dy dx plus 1 equals to 0. So leaving this one here, we have our x squared dy ds equals to, that will be minus 1 minus 2xy. Then making the y dx subject of formula, the y dx will now lead to, you divide both sides by x squared minus 1 minus 2xy all over x squared. So this is how to do your implicit function and you get this answer. Right now, this is the question that was given to them. So I'll first solve this first question. This is number 1 question. I'll solve it because this question is involving both quotient rule and implicit. Alright, so here is the question that we have, and I'll be solving this question. We'll be using these 2 methods. So let's go into the solution. Let's divide this into 2. So we are asked to find the first derivative and also the second derivative. So for the first derivative, we have 3x squared plus 2y squared plus xy plus x equals 7. So like I said, this is an implicit function. That will give me, this will give you 6x. When you differentiate this one, that's 6x plus differentiate this one, that will give you 2 times this, that's 4y. Then you have dy dx. Then you differentiate this, that's plus. Differentiate with respect to x, that will give you y plus. When you differentiate in respect to your y, that will give you x dy dx. Then plus 1 equals 0 because differentiation of a constant is equal to 0. Then we now have collecting like terms. We have 4y dy dx plus x dy dx equals to, I'll carry out the other ones, that will give me minus 1 minus y minus 6x. Then collecting like that, y 6, dy dx is common, that's dy dx into bracket 4y plus x. This is factorization. I can say, since minus is common, I can say minus into bracket 6x plus y plus 1. So we have it that way. Then we can divide both sides by this. That means dy dx equals minus 6x, in brackets, plus y plus 1 all over 4y plus x. So this is going to be our dy dx. But in the question, we are given a point 1, 1, which is telling you this is x and this is y. Your coordinates is always in form of x, y. So we now substitute values. So we have sub coordinates 1, 1. That is for x and y. So that means dy dx. We turn to minus into bracket 6 times 1 plus 1 plus 1 all over 4 into bracket 1 plus 1, which will give us 6 times 1 is 6 plus 1, 7, that's 8. That will give me minus 8 all over 4 times 1 is 4 plus 1, that's 5, minus 8 over 5. Therefore, dy dx equals to minus 8 over 5. But that's not where they asked us to stop. They said we should also do the squared y over the x squared. So which will now give us, that means we are doing a second derivative. So, but we have the y dx to be this. So the y dx equals to minus 6x plus y plus 1 all over 4y plus x. So you now say, let this be equal to u and this is equal to v. That's taking us back to our quotient rule, which is telling you u over v. Then since you use this law. So if u equals to minus into bracket 6x plus y plus 1, or you say minus 6s minus y minus 1, that's your u. So that means the u dx will be equal to differential of minus 6 will give of 6s, that will be minus 6. Then you have minus differential of y, that's 1. Then you put the y dx because it's also an implicit differentiation. So differential of the constant is 0, that goes. Then we have our v to be equal to 4y plus x, and then the v dx will be equal to, that will be 4 dy dx. Then differential of x will be plus 1. So that's it. But recall that dy, or let me say substitute, dy ds equals to minus 8 over 5 in this. So that means our u, du dx, we now come to minus 6 minus 1. Well, because there's dy ds there, I'll put times minus 8 all over 5. So let's have it that way. So this will give me minus 6. That will be plus 8 all over 5. Then you do your, that will give you 5. 1 in 5 is 5. 5, that's minus 30. Plus 5 in 5, 1. 1 times 8, that will give you 8. So minus 30 plus 8, that will give you minus 22 over 5. That's our du dx in unit value, not in variable form. Then we'll find our dv dx, which is 4 into bracket dy dx, which is times minus 8 over 5. Then plus 1. 4 times 8 is 32. That's minus 32 over 5 plus 1. So if you find the LCM, so the LCM is 5. That's 5. We have minus 32 plus 1 in 5 is 5. 5 times 1 is 5. That will give you minus 32 plus 5. That will give you 27. That's minus 27 all over 5. So this is our dv dx. Yeah, good. So we've gotten our dv dx, we've gotten our, so we have all the values for our quotient rule. So that means to now solve this, if you have this, that means your d2y dx squared, that is the squared y dx squared, will now be equals to u. V, what's our v? Our v is 4y. 4y plus x. That's 4y plus x. Then we said du, following that formula, du dx. That's du dx, that's times minus 22 over 5 minus our v. Our v is, sorry, minus our u. That's bracket. There's a minus outside. That minus times this one, we turn this one to plus. Plus 6x plus y plus 1 dv dx, that's minus 27 over 5. You close your bracket, all over v squared. V squared, that's v is 4y plus x all squared. So what will you now do? You now substitute your values of 1, 1 that we are given. 1, 1. So when you substitute that, that means everywhere you see y, you put 1. That will be 4 times 1 plus 1 is bracket minus 22 over 5. Then plus, that's 6 times 1 plus 1 plus 1 into bracket minus 27 over 5. All over, we have 4 times 1 plus 1 all squared. So by the time you solve that, that will give you 4 times 1 is 4 plus 1, that's 5. 5 into bracket minus 22 over 5 plus 6 times 1 is 6 plus 1, 7, 8 plus 8 into bracket minus 27 over 5 all over 4 times 1 is 4 plus 1, that's 5, all over 5 squared. Then we simplify, that means our d squared y dx squared, we turn to 5, we cancel 5, that means minus 22. Then 8 times 7, that's, we have minus 8 times 7 is 56, we write 6, you keep, I'm trying to do 8 times, that's 6, keep 5, 8 times 2, that will give you 16. 16 plus your 5, that will give you 216. That's 21. So you have minus 216 over 5 here. So you add up this one, everything divided by 5 squared is 25. So this will give us, LCM is 5 here. That's 5. 1 in 5, 5. 5 times 22. 5 times 2 is 10. You keep your 1. 5 times 2 is 10 again. That is 110. Minus 110 minus 216. Then all over, that will give you all over 25. So which will give you